Let's learn how to download, install, and use Webots 2023 version on a MacBook. Hey everyone, my name is Kajal and welcome to my channel. On this channel, we talk about how to study and work in the field of robotics. In today's tutorial, I'll go over how to download and install Webots on Mac. I'll also give you an overview of different functionalities within Webots to help you get started. I'll include the timings in the description below, and without further ado, let's get into it. To download Webots on Mac, we'll go on the Cyberbotics website. It will automatically detect your operating system and recommend a Webots version to download. Before you proceed with this, I still recommend double checking the system requirements for Webots. This link will also be included in the description. As you can see, for Mac, we need either Big Sur or Monterey. To check your Mac OS version, simply go to the top menu bar, click on the Apple icon and click on About this Mac. Under the Overview section, you should be able to see your current Mac version. As you can see, I have version 12 Monterey, so I'm good to go. Alright, we'll simply click Download. If you're using Safari, you'll be able to see the downloads icon at the top right corner along with the download progress. I have added it to my desktop. Simply click on the DMG file to open it up. Now you may get this error, so let me show you how to go around it. Click OK. Through Spotlight, I'm going to System Preferences, Security and Privacy. Now do this at your own risk, but here we go. Just click on Open anyway. You should see this Webots icon here, and similar to any Mac installation, you simply drag and drop it in the Applications folder. So that takes care of the installation step. Because we don't need this anymore, I'm just going to go ahead and eject it, and I'm also going to move this to trash. Now to open Webots, you can go on the menu bar, Go, Applications, and you should see Webots here. Alternatively, you can also go to Spotlight and enter Webots. As you can see, I'm once again getting the error. I'm going to go back to Security and Privacy and click Open anyway. Once again, do this at your own risk. You can choose a theme based on your preference and then click on Start Webots with the selected theme. I'm going to skip the guided tour. Now to understand Webots better, let's open one of the sample worlds. On the menu bar, go on File, Open Sample World. Now this is a list of sample worlds provided by Webots where you can learn how to use different features as well as different sensors. I'm going to go for Robots, GC-Tronic and Epoch. As you can see, there's a bunch of options. Let's just go with the line demo and click OK. As you can see, it has opened up a world for us with a few obstacles, robot, and a rectangular arena. Now let's go over different components. Out here on the left is your scene tree. This is a list of all the nodes that are present in your Webots world. So as you can see, I selected rectangular arena here, different obstacles, and our robot, which in this case is Epoch. On the scene tree, you might also see this small arrow. If you click on it, it will show you all the different parameters for this particular node that can be modified. You can change the name, the controller, which is a code. We'll talk about it a little later. And you can also change the translation and rotation. Let's change this to 2 meters. It might look like the robot has gone missing, but if you zoom out, you'll see that it has simply moved outside the viewpoint. Now, another way to change this is by simply selecting the robot in the world and clicking this green arrow to move the robot. I'm simply scrolling in my mouse to zoom in and zoom out. You can also click on the arena and move it around to change the viewpoint. Similar to translation, you can also change the rotation of the robot. Now this can get confusing, so let me show you something that will help you with the coordinate system. On the top menu bar, if you click on View, Optional Rendering, and Show Coordinate System, it will show you the global coordinate system. So as we can see, Z represents up and down. So let's change that 0.5 meters. And you can see the robot has moved in the Z direction. I'm resetting it to 0 meters. Next, let's look at this console bar on the top. The first option is to simply view and hide your scene tree. The next one is to add a node or an object to our world. Base nodes are your building blocks that you can use to build a robot as well as an object. Next is protonodes. These are the ones that are either provided by Webots or created by someone else for you to use directly. You can go through these to find specific objects, or you can simply type it in the find search bar. You can go for something as simple as a ball or another epoch robot. All you have to do is select the node you want to add and click on add. As you can see, we now have two epochs in our world. Next, we have viewpoint. This will allow us to reset it to the initial viewpoint, whereas this gives you a couple of options. So let's take a look at top view. Let's look at another, west view. You can't see anything besides the wall because everything else in the arena is on the other side of the wall. Let's reset it to the original option. The next three are for world. This one allows you to open existing worlds. So you can see a list of worlds for epoch. This one allows you to save your current Webots world. And this one will simply reload the world. Now, because we did not save any of the changes, such as adding the second epoch, when we reload the world, it simply goes back to its previous saved version. Next is simulation time, and I believe this will be different depending on your machine. The next set of functions are for simulation. This is pretty self explanatory. Play for playing your simulation and pause for pausing your simulation. In this case, we have a line follower robot that has started moving forward. You can see the time has moved forward. This button is for moving the simulation one step at a time, which is very helpful during debugging. And this one will simply reset your simulation. These are for taking a screenshot and making a movie and for sharing your simulation. Last one is for volume. I also want to bring attention to our console. So when we run our simulation, you can see it's printing statements. This is again dependent on what is written in the controller code. Even when you compile and run your code, all other information, including debugging, will show up in the console bar. Next, let's look at the editor and our controller code. So all the code written for your robot is called controllers in Webots. For you to run a code, you have to attach it to your robot. You can do this on the scene tree. So if you go to a scene tree, under our epoch robot, there's an option called controller. By clicking on select, it will give you a list of controller codes that are part of this Webots project. So if you have another controller code, but if you don't add it to your Webots project directory on your laptop, it might not show up here. You can simply select one and click on OK to use that controller for your simulation. And clicking on edit will open the code here on the editor. This here is your Webots inbuilt editor. Now, this particular code is written in C, and as I mentioned before, it's a great way to understand how different functions in Webots work. So, to give you an example, let's look at this function called motor set velocity. This basically allows you to give a speed to your motor to drive the robot forward. You're giving it a reference to your motor and speed. Robot get device is a function used to create a reference for this motor. The reason I'm bringing attention to this is for you to reference different components of your robot, you'll have to use the exact name in your code. Now, this information is available in Webots documentation, but I'll also show you another way on how to get this information. On your scene tree, select the epoch, right click, and click on Convert to Base Nodes. Now, when we go under children, hinge joint and device, you can see it's called left wheel motor. Once again, when you start creating your own robots, you can name it as you wish, but make sure you use the same name for your robot node and in your controller code. Now, controller code in C and C++ will have to be built before being used for Webots simulation. Those tools are also available here. This menu bar also has an option for you to create a new file. Now, if you're thinking about writing your own controller code, don't just create a new file. Instead, you'll have to create a new controller. Now, if you've used the older versions of Webot, there used to be an option called wizard in the menu bar to do this. It's now available under File, New Robot Controller. Now, because this is an example, it won't let me create a new controller code. We'll have to either create a copy or start a new project. But for now, remember this: when you want to create a new controller code, don't just create a new text file. Go ahead on the menu bar, File, New, and New Robot Controller. In the next set of videos, we'll go over how to create your own robot, write your own controller code, and also do some fun projects. Before you go, if you enjoyed this video, make sure to give it a like, and if you haven't already, don't forget to subscribe. Thank you for watching, and I'll see you in the next video.